All right, we're in section 2.2 where we're going to analyze conditional statements. So as we start getting into proofs, we're going to start looking into uh, logical statements, and more importantly, we're going to look at conditional statements. Conditional statements take a logical statement and put it into two parts. You have an hypothesis and a conclusion. When you write a conditional statement, you are going to use what is called the if-then form. So the if-then form will be implemented. If-then form basically means is you are going to have some if part which contains an hypothesis, then the second half of it is going to pertain to the conclusion. So when you have hypothesis, it's your if portion of the conditional statement, and conclusion is your then part of the conditional statement. If we have anything that's a negation, that's just the opposite of what the original statement is. Usually you use the words not in front of whatever hypothesis or whatever conclusion you're trying to make, which is like the opposite of what the original conditional statement was. A converse is a conditional statement is you're just simply switching the hypothesis and conclusion. So basically the if will be the conclusion, and then the then portion will be the hypothesis, and then you kind of go from there. Inverse is a conditional statement formed by negating both hypothesis and conclusions. So you're going to look at the conditional statement. That's basically where the negating portion comes in. You just put the not in front of your hypothesis and conclusion. Contrapositive is a conditional statement formed by writing the converse and then negating both hypothesis and conclusion. It's basically it's that you're trying to negate the inverse, so to speak. Equivalent statements are two statements that are both true or both false. Uh, Also here we have perpendicular lines or two lines that intersect to form a right angle. That's going to be important and one of the proofs that we're going to look at in this notes. And then finally, we talk about a biconditional statement. A biconditional statement contains the phrase if and only if, and those statements and converse are both true. So let's do some practice of writing conditional statements using the if-then form. So the first thing that we have is we have a statement here that says all vertebrates have a backbone. So they're pertaining to animals. So what we can say is our hypothesis is an animal is a vertebrate. Then our conclusion will be that the animal has a backbone. So that is our hypothesis, that is our conclusion. So using a conditional statement, using the if-then form, we can then go about say, if an animal is a vertebrate, then the animal has a backbone. Okay, so that is our conditional statement. We used our hypothesis, we used our conclusion to write an if-then um, statement. So same idea here. We're going to again write another conditional statement. We have all triangles have three sides. So triangles are part of polygons. So we're going to say a polygon is a triangle. So that's our hypothesis. Usually it's the first thing in the statement. And then the conclusion we can say is the polygon has three sides. So hypothesis, we have our conclusion. We can then write our if statement stating that if a polygon is a triangle, then it has three sides. Okay. So here we have another conditional statement. This conditional statement pertains to a math equation. So we can say that when x equals 2, x squared equals 4. So the hypothesis is the first part. We got x equals 2. And then we have our conclusion that says x squared equals 4. So this one is pretty straightforward. If x equals 2, then x squared equals 4. So that is how we would go about writing conditional statements using if-then form. All right, so here they're asking us to write the if-then form. They want us to write the converse, the inverse, and the contrapositive of the conditional statement. And then they want you to decide whether, excuse me, each statement is true or false. So we'll go about using the statement, the conditional statement, and then from that we will make conclusions whether the statements that we end up writing are true or false. So here, conditional statement stating that Olympians are athletes. So Olympians, we're going to talk about initially, we're going to talk about that as our hypothesis. And with athletes, we're going to talk about that being our conclusion. So with that being said, we can then say with an if-then statement, so our first statement will be is if you are an Olympian, then you are an athlete. So we go if you are an Olympian, then you are an athlete. Are Olympians athletes? This would be a true statement. Okay? That'd be a true statement. All right, so now we're going to look at the converse. All right, the converse, like we said, is you're just flipping the conclusion hypothesis. So you're making the if portion the conclusion of the original statement, and then the hypothesis is your conclusion in the second part. So to just kind of flip this around, you're going to say if you are an athlete, then you are an Olympian. Is that statement true? That statement is false. That statement is false. You can be an athlete, but you could be a baseball player or you could be a football player and not necessarily an Olympian. So that is a false statement. All right. Certainly you can be um, an athlete and Olympian, but you can be other things as well. Inverse. So now inverse is you're going to look at your first if-then statement, and basically you're attaching the words not to uh, your respected hypothesis and conclusion. So looking at the first one, you're going to say if you are now you're going to say not an Olympian. If you are not an Olympian, then you are not an athlete. That one's false as well. All right, same idea, stating that just because you're not an Olympian doesn't mean you're not an athlete. Like you said, you could be a football player, you could be you know, a cyclist or whatever it is. You don't necessarily have to be an Olympic athlete in order to be, considered knots. So, and here, the last one is you are going to take basically your converse statement and putting knots in front of your respected hypothesis and conclusion. So here we have if you are not an athlete, then you are not an Olympian. If you are not an athlete, then you are not an Olympian. That would be true. Because if you have to be some kind of athlete to be an Olympian. So if you're not an athlete, then you're also probably not an Olympian. That'd be a true statement. All right, so let's take a look here. We have another conditional statement. We have squares are rectangles. So squares are rectangles. So again, talking about squares is our hypothesis, talking about rectangles is our conclusion. So if we were to write this as an if-then form statement, we can say if a figure is a square, then it is a rectangle. So basically what we're asking is, if it is a square, then it is a rectangle. From the characteristics of a square, can it be a rectangle? The answer is yes, this is a true statement, because for a square to be a square, you must have four, you have four equal sides, but also you need to have two sets of parallel lines, and also you must have four 90-degree angles, which that does, and that's what a characteristic of a rectangle is. That's why that is true. Let's look at the converse. Flipping the conclusion and the hypothesis from the original statement, we can say if a figure is a rectangle, then it is a square. That would be false. Okay, so not all rectangles are squares, because the main thing that makes a square is that it is four congruent sides. Inverse. So now we're going to attach knots to the if-then form. So we can say if a figure is not a square, then it is not a rectangle. Okay, so if a figure is not a square, then it is not a rectangle. That would be false, because if it's not a square, that means it doesn't have, you know, two sets of parallel sides, 90-degree angles, stuff like that. So that is a false statement. All right, contrapositive. Also, um, if it is not a square, then it is not a rectangle. That means that a rectangle could have, two sets of sides that are, different. You could have one side equal to another like this, where you have like this is 4 and this is 4, and then this is 8 and this is 8. It's a rectangle, but it's not a square. So, okay, so here it says for the contrapositive, if a figure is not a rectangle, then it is not a square. That is true, because if it's not a square, again, won't have all the characteristics of a square, and the next level down for a rectangle would be square. So that's why if it's not a rectangle, then it automatically is not a square. Okay, so going into what we had at the beginning, we talked about parallel lines. We had the definition of parallel lines, and that definition was two lines that intersect to form a right angle. So we got our definition here. It says the definition can also be using the converse. So if two lines are perpendicular, then they intersect to form a right angle. Uh, if we're looking at this, we can say that since the statement and converse are both true, the definition can be written as a biconditional statement. So here is your biconditional statements in blue here. It says two lines intersect to form a right angle if and only if they are perpendicular. So we're going to practice on how to write a biconditional statement. So here we have a statement which is if two lines lie in the same plane and do not intersect, then they are parallel. So the converse is, again, you're just flipping your hypothesis and conclusion around. So if you were going to say if two lines are parallel, so that's just the opposite, then they lie in the same plane and do not intersect. So basically, you just have to read both of those statements. So like, the first one, this one is the if-then form, your first conditional statement. If two lines lie in the same plane and do not intersect, they are parallel. That is true. If two lines are parallel, they lie in the same plane and do not intersect. That is also true. So we have our statement, our conditional statement, and our converse statement are both true. So since we can do that, we can now write a biconditional statement uh, because those two statements are true. So our biconditional statement will look something like this. Two lines are parallel if and only if. So that's where this is the big piece of the biconditional statement. You got to use the terms if and only if. They lie in the same plane and do not intersect. All right, so again, the main portion of this is instead of writing it as an if-then statement, you're writing it as an if and only if portion for that biconditional. So that's the big key phrase in there. Okay, so we are going to decide, it says, decide whether each statement about the diagram is true. Explain your answer using the definition you have learned. So we just learned about, uh, we talked about perpendicular lines. Perpendicular lines, by definition, are two lines that intersect to form a right angle. Okay, so two lines that intersect to form a right angle. So here, this is the symbol for perpendicular. If you didn't know. So basically they're asking is line AC perpendicular to line BD? We could say that this is a true statement. All right. We can say this is a true statement. We can say one of two things. One, we have a right angle that symbolizes We have a right angle symbol, or we can go about talking about the definition of perpendicular lines. Okay. So the next one here is, I'll erase some things. They want to know if angle AED and angle BEC, they want to know if they are a linear pair. So I had them drawn out red and green respectively. So AED and angle BEC, they want to know if they're a linear pair. This is false. Okay, so because you have to look at the definition of a linear pair. Linear pair, those angles have to be adjacent. So in these particular ones, these angles are not adjacent angles. And since they're not adjacent, they are not a linear pair. All right, so here they want us to decide whether each statement about the diagram is true. And again, we're explaining answers using definitions we have learned. So not only what we're learning today, it's stuff we've learned in previous chapters as well. So they want to look at angle GLK and angle JLK. So they want to know if they're supplementary. All right, supplementary, we know that are two angles that add up, or sums are 180 degrees. All right, so if we look at GLK and angle JLK, they're a linear pair. So since they are a linear pair, we know by definition of a linear pair that they are sums are going to be 180 degrees. So are they supplementary? This is true. And so our explanation is the angles are a linear pair, and linear pairs are supplementary. All right, so last one, they want to know if, I'll do some erasing here. They want to know if G, J, and HK are perpendicular. Okay, so by definition, it's two intersecting lines that cross at a 90-degree angle. Right now, there's no indication that they cross at a 90-degree angle. There's not enough information, so I'm going to say that this term is false at the moment, because right now there's nothing to indicate that the lines intersect at a right angle. And that is being able to analyze conditional statements. Hope this helps. Until next time.